Good afternoon, my name is Hani Abdurrahman, and today I'm going to talk about our project, which involves using satellite imagery uh, to, to detect changes in our environment over time. Our project involves using machine learning algorithms in order to determine any level of environmental degradation, devegetation, and deforestation that could take place within the environment over a period of time. So what this involves is using image processing as well as, just like I've stated, some machine learning algorithms. And so what am I here basically to talk about? Today what we're going to discuss is how we are going to use the three principles of machine learning: supervised learning, unsupervised learning, and reinforcement learning, and how we shall use those three in our project, and how those three will help us to develop our project. First of all, let us address what machine learning is. Machine learning is a subset of artificial intelligence that allows systems to learn and make decisions from data. In our case, we are particularly interested in its application in environmental conservation. So now let us go down into those individual types of machine learning. First of all, we shall talk about unsupervised learning. Unsupervised learning means we are going to train our machine learning algorithm using unlabeled data. Okay, so this unlabeled data basically involves data that is not differentiated. So how are we going to apply this unsupervised learning in our project? First of all, using unsupervised learning, we can group and cluster similar features within the satellite images, similar patterns, similar features. This clustering and grouping of them will show us a pattern, and it will show us some new feature. It can just show us some new details and information, and it could also help us to detect anomalies within the satellite images over a period of time. This ensures that unsupervised learning can show us the patterns of the problems that we are trying to capture. We can use unsupervised learning also as well to filter out unnecessary datasets, and we only remain with the details we need of a particular dataset. Okay, so we don't have to focus on all individual trees and individual grasses. We have to just focus on the overall picture of the whole, for example, forest or the whole savanna grassland. Secondly, we are going to talk about supervised learning. Supervised learning means training an algorithm using labeled data. In this case, the satellite images will have different components in them, which are labeled. Okay. First of all, the algorithm will be able to determine areas which have water bodies, areas which have grass, and areas which are densely populated trees. So like it can determine this is a forest, this is a river, this is grass. So that's how supervised learning is applied. It uses labeled data. And how do we apply this? Just like I've said, it helps us to, for example, focus individually of each of those different components in our environment, and it also helps us to determine a specific outcome. Okay, so because it's a supervised learning. Because if we're looking for a particular outcome, for example, what are the changes in trees, then, or what are the changes only in water bodies, then we just use the supervised learning. Going on to the third is reinforcement learning. And reinforcement learning means that there is an agent in the environment. Okay, if it performs the correct behavior, we shall reward it, and if it performs the wrong behavior, we shall give it a penalty. This is in order to optimize the good behaviors of the agent in the environment. How do we apply this? First of all, let us talk about the environment. In this case, the environment is the satellite images, the location, the region on the satellite images, the forests. The agent is the machine learning algorithm model. And then, what are the penalties? What are the rewards? The penalties will come about when, for example, the machine learning algorithm does not gives you a false alert on some problem. It fails to detect the actual problem. It uh, it does not give you a problem within a specific period of time, as well as does not show you changes that have happened. If there is, for example, a restoration activity that has been carried out, for example, reforestation, and the change has not been detected on the algorithm over a period of time, then we shall have to give it a penalty. When do you give it a reward? When, for example, it correctly detects a change, when it correctly detects a problem, when it gives us the problem within at a faster time, within a shorter period of time. So basically, uh, those are the rewards and the penalties in this case. Let me see. More of the things that lead to a positive reward include identifying areas of deforestation, just like I've stated, identifying successful restoration projects, or detecting illegal logging activities. Where penalties can apply include ineffective conservation strategy, failure to identify any ecological threat, ecological change, and misclassification and giving us the wrong result, or basically the wrong result or the wrong feedback. So uh, let us differentiate these three. Just like I have stated, by definition, reinforcement learning, this one applies the agent being in the environment, where we give it rewards or penalties based on if it has done the right behavior, carried out the correct behavior, if it has not carried out the correct behavior. Okay, unsupervised learning involves using unlabeled data. Supervised learning involves using labeled data, and this one can be used to obtain a specific outcome, and also categorizing the data, the information in the data. However, now I have to come and address some of the challenges that we shall encounter in this project, and some of the challenges we shall encounter while applying these three types of machine learning. First of all, data quality. Data quality is going to be a big challenge, because most of these satellites, the ones that give you images near real time, as well as give you images of high resolution, are usually paid for, and the ones which are free also perform the same purpose. However, they are not as better in performance as the ones that are paid for. Examples of such satellites: we have Landsat, and then we have Sentinel-2. In our case, we are hoping to use Sentinel-2 if all goes well. Secondly is resources. We need a lot of resources. We need to develop more expertise in remote sensing. We need to have access to the satellite images, which will take a certain amount of effort. However, we shall try to address each of these along the ways. Overall, machine learning is a very important principle in artificial intelligence, and by using it, we can be able to address some of the necessary solutions that we have to do in our environment, aligning with the COP15 goals. Thank you so much.